Hi everybody, we're going to look at a specific special case for factoring. Now we're looking at a quick one. Many students find this to be the easiest of the factoring types. This is called difference of squares factoring. So here we go. Let's start off as we always do with a couple of things to look for. Our key look fors are as follows. Our expression is going to have only two terms. So if we see an expression and we're told to factor it and there's only two terms, that's probably a really good indication that it might be difference of squares, and we should be taking that seriously. For difference of squares, the reason it's called difference of squares is because the difference between things is done by subtracting. So the two terms are going to be separated by a minus sign. That'll be in our second clue that we're talking about, this thing called difference of squares. Our third one is that each term is a perfect square, meaning we can take the square root of it and we won't end up with a weird decimal or something like that. We're going to end up with a whole number. So I'm going to give you some examples of that. Numbers that we might be looking for would be 1. You can take the square root of 1, 4, 9, 25, 36, 49, and on and on and on and on and on. So 1 squared, 2 squared, 3 squared. I forgot 16. 4 squared, 5 squared, 6 squared, 7 squared, and on and on and on. Okay? So if we see those numbers in there, that's probably an indication we might be dealing with a perfect square situation. Of course, your variable might be squared as well. So you might have 16x squared. And the square root of 16x squared is 4x. Okay, so we're looking for those terms that indicates we might be looking at a difference of squares. And so our final answer is going to be written in this form. Two brackets next to one another. We'll have our variable at the beginning of each. And then the first one will have minus something, and the first one will have plus something. Okay, so one binomial has a positive in the middle, the other binomial has a negative in the middle. So that's our form for difference of squares. Let's try a few of these out and see what this would actually look like when we're doing our real factoring. Let me put a screen on here. So here's some things just to practice. Let's go through our first example here. We've got x minus 25. So the thing I'm realizing right away is that, okay, I can take the square root of x squared, that's just x, and I can take the square root of 25, that's just 5. So this is going to be x plus 5 times x minus 5. Okay, I took the square root of the x, I took the square root of the 25, and I had a plus in one bracket and a minus in the other. Now if we were to FOIL this out, multiply all this out, we would end up with x squared minus 25. And the reason is a lot of this stuff is going to cancel itself out. So I'm actually going to write this up here just so you can see it. If I go, okay, x times x is x squared, x times negative 5 is negative 5x, 5 times x is 5x, and positive 5 times negative 5 is negative 25. And we see there our negative 5x and positive 5x are equal and opposite, so they're going to cancel out and be 0, and we're just left with x squared minus 25. Okay, so what I'm going to ask you to do is we're going to try a couple of these. I'm going to ask you to do the same thing as a little bit of practice. So here's our first one. I'm going to ask you to pause your video, and I'm going to ask you to please try and fill in the blanks. What would this one look like? Okay, so you would have said, aha, that 4x squared, I take the square root of that, that's already there, it's 2x and 2x. How about the 9? When we take the square root of the 9, what do we get? Well, it's going to be a 3 here and a 3 here. It's plus in one bracket and minus in the other bracket. Okay, that's our first example. Let's have a look at another one. I'd like you to pause your video and try this one out right now. Okay, so we would have said take the square root of 9x squared. That's going to be 3x and 3x. Take the square root of 4y squared. That's going to be 2y and 2y. And we have, of course, our plus and our minus. Okay, so this is a fairly straightforward one, difference of squares. It's usually pretty easy to spot. We're looking for the two terms, the minus sign in between, and then each of the terms is a perfect square, meaning that we can take the square root of each one. Let's look at a couple more examples. Okay, so on this page, I'd like you to pause your video for a moment. Actually, let me go through the first one, and then I'll have you pause and take care of the next two. So let's throw a screen on there. Okay, here's our first one. Sometimes we need to do our common factoring first, right? So if I looked at 27x squared minus 75, I can't do difference of squares, but the first thing I should always be looking for is, can I common factor something out? And I can common factor out a 3. So I divided both those terms by 3 and I end up with 3 times 9x squared minus 25. So I can take the square root of 9x squared, that's 3x, and I can take the square root of 25, that's 5. And now we factored it by common factoring out first, and then doing our difference of squares. Okay, here's 2 examples I'd like you to try right now. Go for it, and pause your video to take as much time as you need to complete these. Okay, here we go. So I'm going to say square root of 16x squared is 4x. 4x. Square root of 1 is 1. Our next one, square root of 25x squared is 5x. Square root of 81 is 9. And we're done. Okay, so that is difference, that is difference of squares, difference of squares. That's our first special case. For the next special case we're going to look at, I want to lead up with something to consider. So I'm going to ask you to consider these two first. I'm going to multiply through here, and I just want you to kind of consider what we're seeing and see if you can notice any patterns. So x plus 5 squared, what does that work out to? Well, if we were to write this the whole way out, it would actually look like this. X plus 5 times x plus 5. Okay, let's multiply that out. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. So let's simplify by collecting our like terms. We've got x squared plus 10x plus 25. Let's look back at our original one right here. Are there any patterns we can see that would get us to our final answer? Well, a couple of things to consider. Our x, I notice I've got an x squared there. We got 5 here. I notice I end up with 25 there, so 5 squared, right? And then our middle term. How does our middle term relate to these two, to our x plus 5? How does our middle term relate to those two? I'm going to do another one while you consider that, and we'll see if we can come up with kind of a general rule. So this one we're going to end up with y minus 7 times y minus 7. Multiply through the brackets, we've got y squared minus 7y minus another 7y. You'll notice it's going to always be two of the same. Plus 49 for the 7 times 7. Okay, let's simplify. Y squared minus 14y plus 49. Okay, let's consider our patterns. Well, we ended up with a y squared. We ended up with a 7 squared. And the one in the middle, how does that relate to our terms? So we notice that negative 14y, it's kind of like we took those two terms and we multiplied them together and then we doubled it. And why is that the case? Well, because we've got two of them right here, right? We got 7y and 7y. Negative 7y and negative 7y. So we actually have the two things inside the brackets multiplied together, but it happens twice, so we're doubling it. Same thing here. We've got 5 times x doubled. So it's in there twice. So 2 times 5 times x gives us that middle term. Let's have a look at our last one to help us feel good about our pattern here. And let's see if we could maybe skip a couple of steps. I think my final answer is going to look like the following. It's going to be that first term squared, so 3 times x squared. And at the end, I'm going to have that second term squared, so that would be 2 squared. And my middle one is going to be 2 times the first term times the second term. So I should be ending up with 9x squared, that's my first term, plus, let's see, 2 times 3 is 6, times 2 is 12. 12x plus 2 squared is 4. So I use that pattern to make myself a nice little shortcut. If I were to multiply all this out, I'd get to the same answer. But I could use the shortcut of saying my first term squared is at the beginning, my last term squared is at the end, the term in the middle is the two terms multiplied and then doubled, because I know I'm going to do that operation twice. Okay, so knowing that pattern, this is going to lead us to our next type of factoring. This type of factoring is called perfect square trinomial. Perfect square trinomial. So on the previous page, we actually ended up with 3 perfect square trinomials. So I'm gonna, I'll do those, circle those in pink. So here's our first one, that's a perfect square trinomial. Here's our second one, that's a perfect square trinomial. And our third one is a perfect square trinomial. With factoring, what we're trying to do is we're trying to go from here back to the beginning. Here, back to the beginning, here, back to the beginning when we factor, okay? So we're going to have to recognize when we're dealing with this perfect square trinomial, something where we've got a term that looks squared in the front, a term that looks squared at the end, and the term in the middle is the square root of both of them multiplied together and doubled. We're going to have to try and recognize that. So here's what we're going to look for. We're going to look for expressions that have 3 terms. That's a clue that maybe this is a perfect square trinomial. The expression has an x squared term with a coefficient of 1 or greater. And it's in this form, something x squared plus something times x plus c, where c is just our constant at the end. And ax squared is a perfect square and c is a perfect square. So we're looking for those perfect squares, things that we could take the square root of evenly, and that's going to tip us off. And the final answers are going to be written in this form, right? Where 2 binomials that are equal to one another, so we could just write it as the 2 binomials together and write it as squared. So this is the form we're going to be looking for. Okay, let's try some examples and see what we can see if we can pick these out and see if we can try them out. So I'm going to do a series here where I'm doing one, and then you're doing one, and then I'm doing one, and then you're doing one, and I'm doing one, and you're doing one. Okay, and we're gonna head through here. So the ones on the right are going to be the ones you're going to try. And they're going to be very similar to the ones I'm going to do. Okay, so right away, here's what I can see. I know I'm going to end up with this as my final answer. Now I want to look at my first term. My first term is 81x squared. So it would be the square root of 81x squared. Well, the square root of 81 is 9, and the square root of x squared is x. So it's going to be 9x. That's going to be my first term. My last term is going to be the square root of this number on the end. So that's going to be a 2, because the square root of 4 is 2. And then I have to decide what sign would go between them. These are all pluses, so it's going to actually be a plus. 9x plus 2 squared. If we were to multiply all that out, we'd end up with 81x squared plus 36x plus 4. Now I'd like you to try it. Very similar problem. I'd like you to try this one right here. So pause your video and give it a shot. Okay, so you've completed that one, and we would have said it's going to be 2x plus 3 squared. And we work all that out, and we'll have our final answer. Okay, let's look at another one. This one's very similar to the one before in some cases, but there seems to be some stuff that doesn't really match up. There's a minus sign in the middle, so that tells me something, and a plus sign at the end. So that tells me that I must have two, it must have a negative sign in my brackets, because when I multiply the numbers, I get a positive, but when I'm adding the two of them together, I'm getting a negative. So it must be a negative sign in the middle of the brackets. But hold on. You can't take the square root of 18 and get an even number, and you can't take the square root of 2 and get an even number. So we have a problem. Well, here's what we got to do. First, we always need to do our common factor. So I can actually pull out a common factor of 2. So that's going to be 9a squared minus 6a plus 1. And now I'm in a position where I've got a perfect square trinomial. 9a squared, what's the square root of that? Well, it's going to be 3a. 1 squared, what's the square root of that? It's 1. And because we have a minus sign in there, I know there's got to be a minus sign in my brackets. So I common factored first, I recognized my perfect square trinomial, and I did my factoring. Here's one that I'd like you to try. Go for it. Okay, so you might have had to think about that one for a while. What is our greatest common factor that we can pull out of here? Well, in fact, it is 3. If you factor a 3 out of there, 48 divided by 3 is going to give you 16. So we got 16x squared. 144 divided by 3 is going to give you 48. And 108 divided by 3 is going to give you 36. And now I recognize I've got my perfect square trinomial. So what's that going to look like? 16x squared, what's the square root of that? It's 4x. 36, what's the square root of that? It's 6. And the whole thing is squared. So that's my perfect square trinomial for this question. Okay, let's look at our third example. Here we go. I'm just going to get myself a little bit more space here. Okay, so the first thing I'm going to do is I'm going to say, can I factor something out of each of those terms? No, it doesn't look like there's a number that divides them. It doesn't look like they all have an m, or do they all have an n? So nope, there's nothing I can factor out of that. But it is a perfect square trinomial, so I can say, okay, what's the square root of my first term? 4m squared. Well, it would be 2m. What's the square root of my last term? 25n squared. That would be 5n. So that one can have a variable in it, and that's totally fine. And of course, I'm going to have a minus in between them because I see the minus right there, and it's going to be squared. So if we were to FOIL all that out, we'd end up at our beginning spot again. Okay, here's our last one. I'd like you to pause your video and give this a try right now. Go for it. Okay, so you've had a moment to give this a shot. Let's see what we get. 144 squared would be 12, so that's going to be 12a. It's all pluses in there, so there's a plus in between them. And 81 squared is 9, and b squared, the square root of b, the square root of b squared is b. So there we go, 12a plus 9b squared will get us to this final answer. Okay, so that is our perfect square trinomial. We're going to stop this video here, and we'll do a little bit of practice. So check in with Mr. Roy. Go for it.